The other project, and we may do this anyway just because it's available and we can use it, we have a lot of people like to focus on wind. Wind is a great source. Unfortunately, we see a lot of people putting up windmills and they haven't done an adequate wind study. And obviously, if you don't have enough wind, you can't really run a turbine. So at the top, the way to do that is with an anemometer device. And we have one of those, and it's actually coming down from an existing site that we have that we've been testing for the last year in new fields. And we can put one of those up around here somewhere. And we can, and this records data every 30 seconds, actually. And so we can output that data and look at whether a wind turbine could be supported on this site. Now, when you have a wind, when you're looking at wind, you have two issues. You have your operating speed of a turbine, which means how fast the wind has to blow to keep the turbine spinning so that you're generating electricity. And then you have what's called the cut-in speed. And this gets ignored too often. And so you may see a turbine listed, and they often do this. They'll say they operate the best. It operates at a low speed, like 8 miles per hour. What they bury sometimes in their equipment literature is you need a cut-in speed of 12, meaning you have to have a higher wind temperature to get the thing starting to spin. But once it's starting to spin, a lowered speed will keep it spinning. And that's because you have a lot of inertia in an object that's at rest. And so to get it spinning, you may have to get 12 for a little bit and leave it at 8 to spin. So if you get a wind like this, you may have 8 or 9 miles an hour of wind, but guess what? Your turbine will never start. And so we have found that in places that have an average of 8 miles an hour, you need to be really careful about making sure that there's enough 12s to keep the thing running. Has anybody seen the wind turbine in Newburyport? There's a big one. Have you seen that one off the side of the road? It's a huge one. There's another one down in Hampton on a telephone pole right on the side of the road. It's about 7 feet in diameter. The one in Newburyport is, I think that's like a 250 kilowatt. The one in Hampton is about 3. So they come in all different sizes and shapes. The most often seen one looks like a propeller. There's a new version out that it looks like a barrel. It looks like somebody took a barrel and basically cut it in half, and then they put the halves like this. And so from the top, you look at it, and it's kind of like it's called a vertical axis turbine, and it looks like this, and then it goes down to a pole. And the reason this is a good idea for some cases is because this kind of turbine handles way more speeds. So its cut-in speed is more like 6. And then the other aspect of this turbine is it'll handle speeds at a much higher level. These turbines shut down at about 40 miles an hour, 45. Some of them go a little faster. But if they get up to a certain speed, they have to stop because they're actually going so fast that they start to, pieces start flying off, and you don't want that to happen. These, there was one recently up at Mount Washington that went up to 140 miles an hour, and it was still generating electricity. So these are much more resilient. The problem is that they're less efficient. So you get a wider wind signature, but you're producing electricity less efficiently than these. And I don't know why that is the case. I think there's only a couple of different models of these out. The tower that we have for the anemometer is about 35 feet. So we can either mount it on the ground or mount it on top of a building somewhere. It requires guy wires to anchor it. We had it up in Newfields in one of the storms last year. We didn't guy wire it, and we had it bolted to the side of the building. We thought it'd be okay, but we came out one day after the storm, and the tower was bent like that. So that's what we can start soon.
Now, what kind of readings have I'm just curious because it'll probably be fairly similar. What kind of readings have you been getting in Newfields?
We've been getting some pretty good readings, actually. We're not worried about the averages anymore. We're definitely over 8 miles an hour in the average. What we've got to go through now, and the company that puts out the anemometer actually has a program that sorts through all the data to make sure that we have enough peaks so that we get the right kind of turbine for that site. But one of the things that we think it makes Newfield such a good site is, I'm going to try to draw this. There's the Great Bay, and you know, a lot of wind comes off the ocean, and what we think helps is that that wind kind of gets channeled by the land a little bit, and so you get some pretty increased wind speeds. Their wastewater treatment plant is right here on the Swampscott River, and so we're hoping, and that's why we chose this site rather than a hill. We actually looked at a hill in Newfields, and we thought, all right, this may actually be better because it's down by the river. And so we think we picked up a couple of miles per hour just by the amount of wind that comes off the Great Bay and gets focused into the mouth of that river. Now, when I walked over here, I looked. It looks like the topography goes down a little bit, so we may be at a point where we can find a good place and put it up. And if all else fails, then you know we may not have a justification for this kind of turbine, but we could look at one of these instead. Any ideas for projects or anything you want to do or that you've heard of or anything like that? What?
Can I ask a question?
Yeah.
Does anybody here have at home any types of systems, whether it be solar or wind or geothermal?
My neighbor's putting in a hydroelectric because he's got a river.
Really?
Get a closed year round, yeah.
That'd be cool.
He just has solar panels.
Yeah.
Just yeah.
What about the geothermal thing that takes the temperature from the ground and brings it to the pool? Keeps it across the temperature. You know about that?
Geothermal is great. I know that Nathan talked when he was talking about doing something at this facility. A geothermal company approached him, and he said he'd be happy to hear what they could do. There's a couple of challenges with geothermal on a building this size. And one is the most expensive part of a geothermal system is the wells. And so the more wells you have to drill, the more expensive it is. And this building, because of this, how much heat it uses, you know, you'd be spending a lot more money drilling wells. You're better off spending that money trying to tighten up the building and get it down to the place where you can cut out some of these wells and then look at it. The other problem is most of the geothermal systems are made for air temperature control. And you know, you don't get, these buildings are all hydronic, meaning there's hot water traveling through the building and then it's blowing air over that hot water. In a geothermal system, they're usually for forced air, whether it's cooling or heating. And so it's hard to have a hydronic system. I think the estimated cost, they just gave them a roundabout number of something like $1.5 million to put a geothermal system into this building, which would be cost prohibitive. The other thing right now, and this is where you get a lot of challenges associated with loss, if you put in a geothermal system now, the utility company will require you to have some kind of backup, which doesn't make a heck of a lot of sense to me, and it's unfortunate because it adds to the cost of the system. And so it's not clear why that's in place, and I think a lot of people are trying to get that changed. So you know, you can find even for a residential house, the geothermal system, you have to pay $30,000, $35,000, then you have to add on to that because you have to have some kind of backup system. But I think there's a lot of people trying to get that changed.